All right, GAC Spartans, hope you're doing well today. This is Coach Johnson speaking. We're about ready to dive right in on Algebra 3, P1 to P5. If you could for me, just to make sure that everything's good, I'm going to give just a second for people to text in the questions they have, as well as to make sure that the YouTube link is working. So if you could just a couple of you, just text me to say that you can actually hear me here. I think you can, because I see a couple of views down there, a couple of viewers. So that's fantastic. Also, we're going straight off the review, P1 to P5. Seeing the viewers keep racking in. I'm really pumped about that. Thanks for showing up today. But if you could just text me your question off the get-go. All right, sweet. Anthony, love it. I love Pete getting in here, and we'll rock and roll. So just put those questions in. I'm going to start on number one. That was the first one that people said they had a question on. So we're going to look at that one, and then we're going to look at the other ones as well. I've never done this before. Usually I allow basically my face to be seen. I kind of introduce it and kind of go from there. Right now, I'll be very real with y'all just so you understand. Right now, I'm feeling really bad. I'm not feeling very good today. Some of you knew I said some crazy things in class on Friday, and for that, I'm sorry, but I'm still not feeling good. It's been a long weekend, and but with that being said, I know we're going to get through it, and I know we're going to get through it together. Before we get started, though, I want to this sounds different on a podcast, but what I'd like to do is just pray for this podcast that would be clear. And then also I'd like to pray for y'all's tests both on Monday and Tuesday. And so we're going to go quick, and then we'll get started on number one, and then there's some other questions that you have as well. Let me start with that, and then we'll rock, all right? Father, we just pause for a moment, and we know that everything's from you. And even on a YouTube Hangout podcast, Lord, we can talk to you, and that's pretty cool. And right now I know I'm not feeling very good. I know there's other people feeling the same. I know maybe some people stressed out about tomorrow and Tuesday. God, calm nerves. Please help us do the very best that we can, and help this podcast to be beneficial, that it bring honor and glory to your name. Lord, we do love you and thank you. In your name we pray. Amen. All right. Let's roll. Maybe you're some NFL football, so we're going to get it rolling here. For some reason, there's some mistakes or mess ups. Please text me or do whatever, and we'll go from there. Okay, let's rock. Now, in numbers 1 and 2, it's pretty simple on these first two, because it's simply just trying to figure out what they're asking for. So the big thing in any word problem is trying to dissect. All right, what are they asking for? Well, first they give us a graph up on top. Then they also give along with that percentages along. Sorry about that. I'm going to turn it off. There we go. There's going to be two things in this. First of all, there's percentages, and the second thing is age. So what it asks is this equation where X represents the amount of years someone lives, and P represents some sort of percentage. But I'm trying to figure out what P is as far as the percentage when the age is 21 years old. So when 21 is our X, we're going to 21 in for X and try to figure out how we can solve it. So as we do that, we'll have P equals negative 0.05, and we're going to square it, plus 3.6 times 21 minus 15. Now, PEMDAS says that we're going to start with exponential, then multiplication, and so on and so forth. Actually, first thing is we have any parentheses here. Multiply that by 0.05 or negative 0.05. We're going to get negative 22.05. All right. Multiply that by 21 to get 75.6. So we're going to put 75.6 there. And so what we're trying to do of age. So as we solve for this, we just kind of combine all this together. So we're going to subtract and add everything we have. The numbers are right. So especially today, because again, I'm having a hard time seeing. So for some reason, again, we're in this together. But I got 38.55% as my answer using the equation. The next part says, did it overestimate or underestimate that percentage? When basically it means, did the equation, did it overshoot it? What the graph says, or did it undershoot? Well, if you go back to the graph says that at 21 years of age, 35% of students or 35% of people had HIV, where the equation is 38.5. Really estimated what the reality was with the graphs. We just say it's overestimated 38%. You could see how much it overestimated, but I don't think that's necessary. Oh, it does say. It says by how much you subtract 3.55% overestimated. And so that's kind of what we look at there. Some of you, maybe I didn't put this out there, so I'm going to let you write. Again, you can pause or under whatever. But if I ask a question, it's my cell 770-757-2240. So feel free to text me those questions. My class or not, if you're watching this podcast pre-game, I would love to be able to touch base with you on that. So we're going to look at some more here just a second. I want to make sure, again, it's free game for you. All right. Awesome. Giving some shout out real quick. I know A there. Love it. Anthony. AC. Thank you, Anjali, for telling me that you can hear me there. And then I've also got T Rabbit, or Rhombus as people call him, in the hood. So we're going to take a look at two of them here. T Rhombus says he wants to take a look at 17 and 23. So we're going to do the rhombus there. Here we go, rhombus. This is for you, okay? T rhombus. Let's take a look at it and go from there. All right, so 17 and 23. Yeah, 17 is a good one. Awesome. 3 square root minus 2. Now, anytime we do multiplication of radicals, we do not have to have the same radical when we simplify that, apply that. However, if we were to add and subtract these, they have to be the same exact radical on the inside in order to add and subtract. That may not make sense, but maybe this will help you. The best thing that I could do is take 54, divvy all of these. So what goes into 54? You remember 9 and 6 go into 54. And so because 9 and 6 make up 54, look at one of those and see is the square with either 9 or 6. Well, we know that 9 is a perfect square, which is 3. So we could bring a 3 to the outside to where not only is it a 3 out here, but now another 3. Remember, don't take the full 9, just the square root of 9. Now, as I look at 6, you'd have 2 and 3, but there's no pairs there. So 6 stays on the inside. So it should make sense to you that 9 is now on the outside with a square root of 6 now on the inside for number 1. So we got number 1 simplified, and we're good. 24 be different. What numbers make up 24? Well, we know 4 and 6 do. Well, we know what is a perfect square. Well, the perfect square is 4. We can bring a 2 to the outside just like we did on the previous one. So now we have 6 left over with, again, 6 does not have a pair. We saw that here. So now we have minus 2 times 2 is 4. Again, you multiply those, right? Don't add them. Multiply those on the outside. And then what's left on the inside? Well, we have that 6 here that doesn't have a pair. So we'll leave the 6 on the inside for the second one as well. So we got number 2 checked off. Now, what makes up 96? Well, again, I can do the same thing. What makes up 96? Well, I can divide 96 by something I know. So if I divide this by 4, I believe I will get 24, and 4 multiplied equal 96. Well, 4, the square root of 4 is 2. So just like before, I'll bring a 2 to the outside. So what about 24? Can we break it down to? Well, we could do now again 4 and 6. The square root of 4 being 2 again, so bring another 2 to the outside. Remember, we multiply those. And since 6 is by itself, it does not have a pair, so now we have minus 4 square root of 6, because 6 does not have a pair now. Again, that is the third one. Now with the fourth one, we could say what two numbers multiply to get 63? And again, you see the same pattern. 3 times 21, 63. 21 breaks down to 3 and 7. So remember, when I break it down, you don't use it. So we've broken it down as much as possible. So now we could do a pair here. And we know that 2 3s are there, so we'll pull 1 3 to the side. And remember, we'll leave it 7 on. So now we have 3 times 4. Remember, multiply them. We get 12 square root of 7. So once I see this, that this right here stands alone, 12 root 7, because there's nothing that has that same root. That means we can't add together. Now these we can, even outside in all of them. Since the insides are the same, you could say 9 squared root of 6 minus 4 squared root of 6 is 5 squared root of 6, and then 5 squared root of 6 is just 1 squared root of 6. Well, 1 squared root of 6 we could just put as square root of 6, and so now square root of 6 plus 12 square root. And so again, that would be number 17, and that's how we would approach that one on a test. Again, break it down. That's the biggest thing. Break it down and be solve in a better way there, okay? Now, 23 is a good one too, because on this one, I always in any exponential, whether 23, whether it's, try to look up top here, 11 is a really good one to know for the test. 10 is a good one to know. Whatever always try to see, can I simplify prior to then taking the exponent to each? Well, since we know 15 divided by 3 easy, to where now I have 3/4 all over x to the 1/2. Now remember, if I have something that's on the bottom, one way that we can do it, and again, maybe your tutor did something different, and if so, good on you if something else makes sense to you. But if I brought this up to the top, I can do longer x to the 1/2, but x to the negative 1/2. So if I were to combine x's together, I would now have 3 to the, well, the negative 1/2. Remember, in this, we combine, add, and subtract together. Don't multiply the difference, right? X to the third to the second, multiply to get x to the sixth, where if we get x to the third times x squared, that's where we add them together to get x. That's very important for tomorrow. Very important. Please make sure you understand that. All right. So as I combine these together, add and subtract them together, I multiply the top by 2 to get common denominators. So I have now 2 over 4. 2 over 4 is to the 1/4. So now it should be 3x to the 1/4. Should be, and since it's positive, we could leave this and solve it and kind of go from. So again, that's how you would do number 23 on that specific problem on that one. All right. All right. I think getting a questions, throw them out there. Just got one from Caroline. Appreciate you for listening, Caroline. Number 20 podcast, please, just like a YouTube video, go back through. You won't offend me by pausing me or doing any of that, or even skipping me. That's fine too. Now on this one, 5 plus 1, all over the square root of 3 minus 1. Now in any, remember, don't like a square in the bottom. Why? That's right. A lot of you said it, because it's like kissing your sister. It's weird, awkward. All right. I'm not be feeling good. I can still crack some jokes. All right. One is to get rid of this square root in the bottom is we multiply by its conjugate, both top and bottom, right? You remember. So in the bottom, not only do I multiply by 3 and 1, But now we change the middle sign to square root of 3 plus 1. But to the bottom, got to give some love to the top. The one I do the bottom first, and then I'll do the top. So square root of 3 times square root of 3. Remember, we multiply both sides and insides. When we do that, square root of 9, right? Well, once I do square root of 3 times 1, makes sense. It should be square root of 3. Now, we've done this first part. Negative 1 times square root of 3 is negative square root of 3. And negative 1 times 1 should be negative 1. So we'll cancel here. And 3, because the square root of 9 is 3, minus 1, we should get 2 on the bottom. So we'll have the bottom there. The next thing we need squared by square root of 3, because now we're going to the top, right? Again, multiply outsides and then inside to the outside. So we multiply square root of 5 times. Next, we do square root of 5 times 1 to get square root of 5. So we've done that part. Now it's this part. 1 times square root of 3, and 1 times 1 simply is 1 there. Okay? All right, roll. It's still sufficient. Big thing, I can't multiply when I don't have the same square root. Notice here, I could do it here and here because we're multiplying. But when I add, ultimately, I cannot add them when you do not have the same square root. All right? And Caroline, hopefully that helped you there. Hopefully that helped you with that question. All right? All right. Awesome. It's a great question there. I've got questions coming all over. Someone asked me to do number 17. I think if you go back through the podcast, I think you'll check that out. So let's do number 12. Okay, let's do number 12. This one says write without exponent. This notate. All right, 75 times 10 to the negative fifth. Okay. I also want to do the number 13. Can we do number 13 as well? Here, number 12. Okay. All right. Now on the top, when we look at this to change it from sign notation to regular, the important thing to remember is that if we have this value where it's the negative fifth, the negative means that it's going to move towards the left. The positive means the right. If it's the negative fifth, this decimal is going to make it the number smaller and smaller and smaller, right? 1, 2, 4, 1 to the fifth here. So that means in each of these categories, each of these spaces, we're going to have a 0. So the answer should be 0.007 5, and that right there would actually be the number that changed from scientific notation to an over there. And this from the real number scientific notation. Well, scientific notation states that it actually follows the first natural. So after that's when we put multiply or times 10 to the some sort of power. Put in actually go to 3, 5, 6, right? So it's going to be the 6th power, but a lot of people struggle whether it's positive or negative. I changed this to up here. If I was going from this way to the right, that means this was going to remain positive. Because it's the larger number and not a decimal, we know it will keep that 6 at a positive, and we'll keep it right there. And that will be our answer. That's how we do number 13. Okay? So great questions. Hopefully this is helping y'all. If you could get it or throw it out there, my phone or all of my numbers in the text messages right now are on. So if you've got some more, throw them out there, and I will be glad to look at those together. So if you have any other questions, throw them out. Remember that big deal just on the test, both Monday and Tuesday. Remembering that. Trying to think of another one that would be good. Let's do number 21. I just think that's a good one. Yeah, 21's a good one. 64, 21, 22. Just like those. Sometimes you just get problems that you're just like, man, those are good stuff. It's kind of one of those things, good stuff. I just got another question, number 10. So I'm going to look at number 10. Let me look at number 21 and then 22, and then I'll be right with you on that one. All right, 64 to the 2/3. Now, remember 2/3 can be broken down as follows. We could say 64 to the 2nd power, and that whole thing is to the 1/3 power. Now, remember 1/3 means the same thing as to the third, the same thing. All right, it's just like its gangsta name. All right, same thing. So if I have 64 squared, I take the third root, I can tell you to do is first take the third root of 64, and once you solve for that, then square it. So let's do this. Before we square it, let's first say what number multiplied by itself 3 times gets me to 64. If you think about that, I think the only value that we could think of is possibly 4, right? It's 4 times 4 times 4 will get me back to 64 there. So what we're going to do is we're going to say 4 is the value of the cube root of 64, and then I'm going to take that and I'll square it because I haven't done that yet. So once I square it, 4 squared is 16. So the answer of 64 to the 2/3 would be 16. All right. Now take a look at this one. 27, same thing. We're going to take 27 to the -4th power. Well, it becomes pretty hard to do if you think about it, especially without a calculator. So we're going to keep it 27 to the -4th power. And remember, this is going to be to the 1/3 on the outside, or it's the same thing as the cube root. So before we do the -4th root, or the -4th power, let's do to the 3rd root first. So what multiplied by itself 3 times gets me 27? Well, again, I think the answer would be 3, so we're going to put that there. So now I'm going to take 3, take it to the -4th power. So 3 to the -4th would be a value that we'll end up getting there. And so remember, anytime we have a negative exponent, the same as 1 over 3 to the 4th. Well, 3 to the 4th is 3 times 3 times 3 times 3. I think as we solve that, I think it's 81. So 1 over 81 would be the answer for number 22. That's how we would solve for it. Okay. Awesome. Hopefully that's helping you there. Got a lot more text here. Appreciate y'all throwing them out there. I'm going to do number 10. Then I'm going to hit up all the other questions that you have, hopefully in the order that you sent it. All right, let's do this one. X to the -2nd and y is going to be all to the -3rd on the outside, okay? Now, in this next one, we also have the x squared y to the -1st all to the 3rd. Now, if for some reason, like in number 11, you have that power on the way outside, what I would do is try to simplify the inside first before moving to the exponent on the outside. But the problem with this one is because these two exponents are different, I can't do that. So let's do this. Let's take x to the -2nd to the -3rd and y also to the -3rd. So remember, x to the -2nd to the -3rd, we multiply those because it's an exponent to an exponent to get x to the 6th. And with y, this is like a hidden 1 up here, right? So 1 times -3 will be y to the -3rd. Same holds true on the bottom. Squared to the power will be x first to the 3rd power is y to the -3rd. Now, as I look at this, one thing that I always simplify is I bring the bottom to the top. I start from the bottom and I'll be there, okay? And then I realize I'll start from the bottom and the whole team will be there. So if I bring the bottom to the top, x to the 6th now becomes x to the -6, because again, if I change it to the top, the sign changes. Same thing with y to the -3rd. This will now be y to the 3rd. So now I add these together, right? I don't multiply them. I add x to the 6 times x to the -6 to get x to the 0, Well, that's kind of weird. Well, we'll come to that in a second. And the same thing with the y to the negative third and y to the third. It gets y to the 0. Well, anything to the 0 power is 1, right? So it'd be the same as saying what's 1 times 1. 1 would be 1, and we just right there. We came out with a weird answer there. That's the idea of what you would do on that. All right. Awesome. All right. Number 9. Yeah, that's a good one. Number 9. All right. Number 9 is 1. Let's see here. 5x to the third y squared. Awesome. And negative 2x to the negative 11th y to the negative 2nd. Sweet. All right. First thing we want to do is when we multiply these, we want to multiply the coefficients first. So negative 5 times negative 2 is 10. That helps me out. Now, once I multiply those together, I kind of list all of the variables down below. Okay? Some of you may not have to do this. Sorry about that. Some of you may not have to do that. You could skip that step, and that's okay. But what you want to do now is combine x to the third and 11. When I multiply those, remember, exponents are added when I multiply that together. Remember the difference between x to the third to the negative 11 compared to what you see here. When I add those two together, you should get x to the negative 8. And when I combine y squared and y to the negative second, I get y to the 0, which is just be 1. So x to the negative 8. And if I was trying to get to where all exponents were positive, which is the test tomorrow, we could put it on the bottom, because anything negative exponent we could change by either putting it to the top or bottom of where the opposite of where it currently is. So we leave it as 10 for x the 8. Okay, let's do this. Number 33. Love it. Let's do number 33. Third minus 8. All right, it's a good one. Remember, you could even kind of remember these steps as you get factoring, okay? Teach me how to factor. Everybody factor. All right, first step is this. So GCF. You could figure that out to GCF, okay? The second thing I look for is how many terms do I have, right? If I have when I have 3, when I have 4, right? 3 that we could possibly have. So GCF is the first thing, and then the amount of terms is the second thing. So if it's probably going to be a trinomial, you either do 2 numbers multiplied equals C, add B, or A times C method, or check and guess method. That's something. You'll next month, or whatever that may be there. 4 terms, you're looking for grouping, right? Group the first 2 and last 2 together. And then a difference of 2 squares, or you look for cubic. Okay? So I look at this. Is there a GCF of this? The answer is no. Okay, we're good. Second thing is how many terms are there? Well, there's 2, right? There's 2 of them. So since there's 2, can I take this? Can I take the square root of both of these? The answer is no. And I can't take the square root of y to the third. So because of that, we know we could probably going to do cubic. Take the cubic both these with A and the second one being B. That will help for where we're headed. So if I do the cubic of y to the third, that answer will be y. Where if I did the cubic of B, 2. Now the A and B, don't let that get you hung up. I'm going to show you in a second how it's used. But I just want to make sure you at least know how to find both of the first step. The second is this. I'm going to give you these formulas tomorrow and on Tuesday. And the important thing to remember is that with a cubic, A cubed minus B gets the following formula. It's A minus B times A squared plus AB plus B squared. You're plugging where A is the first one, the cube root of the first one, and B is the cube root of the second. So if I were to plug this in, I would get y minus 2, my first factor, right? Because a and a squared would be y squared. AB would be 2 times y. We just say 2y. And b squared would be 4. And that right there would be cubic formula with a cubed minus b cubed. That would be it simplified. And so you could leave it just like that with problem. Number 33, Anjali. Hopefully that helps you as well. To the point where I don't have any other questions. Does anyone have any other questions they want to throw out there? Maybe you saw some on the review that you really struggled on. I'll kind of give another 10 minutes, kind of go from here. So if you have one, throw it out. I saw another one on Remind 101. Let me look and see. So I know we're good. All right, good. If you've got another one, throw it out there. Another one, throw it out there. I'd love to get one from y'all. Number 11 again. It's a good one. All right, remember on this one was one that I was kind of talking about, I referred to one before, and then perfect. -9 x to the -4th, y to the -2nd. Now, all of this to the same power. What I would consider is to simplify first on the inside, beating in here, then move to the outside. So let me show you what I mean by that. Simplify here. -27 divided by -9 would be 3. And remember, these exponents are the with the exponents could change the sign of the exponent. So now we got x to the 3rd, y to the -5th. Bring these to the top. X to the 4th and the 2nd. Get the -4, -2. So when I combine these together, I get 3x and y. X to the 3rd to the 4th. We combine those or get x to the 7th. Whereas with y to the -5th and y squared, we add those together, get -3rd. So when I look at this, 3x to the 7th, y to the -3rd, and though I love to get them positive, I'm not going to do that. So the negative power here, right? So well, this means that it's going to go to each of these three as far as their exponents are concerned. So this is going to be like 3 -2nd power, 14th power, and y to the +6 because we multiply there. So anything that has negative exponent on the 6 is the only thing on top. And on the bottom, we'll get 3 to the 2nd. Again, if I put this to the bottom now, I change the negative to now a positive, right? I can go back and forth. Same thing with the x to the 14th on the bottom. So when I simplify, I get y to the 6 all over 9x to the 14th. And that right there would be my final answer. Just in the way that I did it. Some of you may do it differently. Some of you may do the exponent first, multiply by the exponent, or take it to the exponent first. I find that to be more tricky. So if it's all to the same power, and then afterwards, then take the power once I've simplified to the inside, okay? All right. Sweet, sweet. I think I heard something else go off on it over here. Number 11, yeah, just did that one. We're good there. Trying to see here. Number 2 is very similar. I'm just looking. Number 3 is pretty easy because you just subtract one from the other of it. Number 4, simplify by adding like terms. Make sure that you have like terms there. Number 6 is a lot of people missed on the quiz last time. That one real quick, just to be sure. So we got this here. All right, sweet. One thing that we'll do is we're going to work inside parentheses first, right? But I can't go this deep because you can't combine that. So what we're going to do is we're going to distribute that negative across. So in this bracket, we have 3 minus 5x plus 11 with this negative 2 hanging out here. Now, do not combine 8 because negative 2 is going to distribute to whatever I get on the inside. So do not subtract. So now I combine inside of the parentheses first to get 14 minus 5x, again with this negative 2 hanging out on this outside. So we're going to distribute negative 2 out to get negative 28 plus 10. And again, this 8 is kind of on the outside too. Awesome. Now, after I combine, now I've done that, right? I've distributed negative 2. So I can now say 8 minus 28 is negative 20. And then include that 10x. Remember, adding like terms, I can't add these two together because they're not like terms. And so we leave that as is for, again, that's for number 6. So if you're looking at that one, number 6 there. All right. All right. 24 is another one. Make sure how you know how to distribute on 25 and 26. 16. Make sure you know how to do as well. Means a good one. Let me do number 16, and we'll go from there. If you have any other questions, throw them out there. But if I don't get another one by the time this one we're with, then we'll wrap it here. If you have more questions, you can come in tomorrow morning. If you have the same square root on top and bottom, meaning the same radical with nothing on the outside, you could not do this for this, right? You could not do it for this. Only when it has the same radical with nothing else on the outside. What you could do is put all of this underneath one rule. Okay? So do that. So if I were to do that now, I could divide this 3 into 24 8 times. X and X 5 and bring this X to the top because I changed the sign, right? So if I add those two, it'd be the same as saying the square root of 8 to the third. Well, to divvy 8 out, square root of 4 is 2. We pull a 2 to the outside, leave that 2 on the inside, and then there's 3 x's. So we leave 1 on the inside. So we'd have 2x square root of 2x. So that would be how we could go approach to make it easier on ourselves. All right. Hey, I hope this has been helpful for y'all. I haven't gotten any questions. Also, feel free, come on by. I'd love to touch base with you around 7:15, and we'll be start there. So I'd love to go those questions. Again, love you all a lot. I hope you all just tear it up tomorrow on that test. Do well, and again, love reviews, study this podcast, and you should be good to go. Anyway, see y'all. Have a great